So now that we're a little bit more comfortable taking the trigonometric ratio of all sorts of different angles, let's talk about some applications of those trigonometric ratio. So first off, I want everybody to immediately freak out because as soon as I say applications, that means one in particular thing, which is word problems. Everybody panic. We're going to start using math in the real world. So with that in mind, let's talk about what these trigonometric ratios can actually help us to do. So given a right triangle situation, usually something between vertical and horizontal with a slanty side as well. So given a right triangle, if you know one side and one acute angle, and your goal is find another side, you can set up a trigonometric ratio that will assist you in finding such a thing. Now, occasionally we'll have to do this process multiple times in a given problem because we could potentially see multiple right triangles in a situation. So, generally speaking, you're going to be able to model something with a right triangle, with a known angle, and a known side, and an unknown side. Now, the way that we're going to do this is, first off, identify or draw yourself an appropriate picture if needed. So, from the perspective of the angle, from the perspective of the acute angle, what side is known and what side is unknown. From the perspective of the acute angle, what side is known and what side is unknown. Once you have the side that is known and the side that is unknown, it'll be up to you to use the appropriate trigonometric ratio to relate the two of them. Now, given that we talked about using the calculator to approximate answers, the calculator is only capable of dealing with the sine, the cosine, and the tangent. So, whichever pair you have, whether it's opposite and hypotenuse, adjacent and hypotenuse, or opposite and adjacent, you can select the appropriate setup. Once you've set this up, plug in what is known, and then use algebra to solve for what is unknown. Plug in what is known, then we can use algebra to solve for whatever is unknown. Now, with these problems in setting up things that are right triangles, very frequently you're going to see things that are horizontal interacting with things that are vertical. So with that in mind, I wanted to introduce a couple of pieces of terminology that get used. So for those that are unaware of my guy over here, this right here is Chugs the Stick Figure Man. Chugs the Stick Figure Man is a buddy of mine from graduate school. And anytime there's any sort of questionable situation that he's in, chances are pretty good he'll be involved. So suppose that you hire Chugs the Stick Figure Man to be your babysitter. So naturally, Chugs the Stick Figure Man is going to put the baby right up here where he can easily spot the child. Now, don't get me wrong, Chugs the Stick Figure Man is, of course, super attentive, so he's always got eyes on the kid. Now, the way that this relates to what we're doing here is Chugs the Stick Figure Man's line of sight creates a certain angle with the horizontal. That angle that's created with the horizontal is known as an angle of elevation. So anytime you have a sight looking up at something, we refer to the angle that's created with the horizontal as the angle of elevation. So angle created with a horizontal. Now, as he's down here waving frantically at the child, saying coochie coochie coo and whatnot, the baby is going to be looking back down at him. And the baby looking down is also going to create an angle with the horizontal. This one up here is referred to as an angle of depression. Depression simply refers to looking down or being down. The good news is that these two horizontals would constitute parallel lines, and the angle that cuts through them makes these alternating interior angles. And according to geometry, that means that the measure of the angle of elevation is going to match the angle of depression. So we'll be using that to set up some right triangles and make some calculations.